In the last video of Chapter 6 is how to do binomial probability problems with your calculator. Therefore, since you are using your calculator in this section primarily, it would be a good idea to have it by your side so that you can quickly find the keys and do all the calculator commands with me in the video. So go ahead and have your calculator by your side and ready to go. Alright. At first we calculated binomial probabilities using a tree diagram, which sucked because there were a lot of different ways that if we had, if n, our number of trials, was high enough, our trees got to be very complicated and very large. Then we looked at using the formula from the last video. And the formula again, which we will have to use to show for full credit here. Back a little bit. If we want to know the probability that our random variable was equal to a certain number of successes k, that was really equal to our n combination k times the probability of success to the k power, because we want to have that many successes, and then we had our failure rate, our 1 minus p, times the n minus k power, which ended up giving us our number of failures that we needed. Okay, now there are a couple of commands in the calculator that we are going to be using. One of them is called Binome Pdf. The other one is called Binome Cedia. Now, if you remember, whenever we would do work with the normal distribution, we would use normal Cedia. And if you ever notice, there is a normal PDF command, but we never use it. Okay? And there's a reason why we never use it. But I won't really go into too much detail about that. But we will be using both Binome Pdf and Binome Cedia in this video. And you really need to understand the difference between them. And really, in a CDF case, you could use PDF. So we will talk about when there's cases of having to use Binome Pdf multiple times, of how you could really shorten that down and just use a CDF, Binome Cedia. They are located, if you would like to go ahead and find where they are located, in the same place that normal CDF is located, and some of you might have even forgotten that, and that's if you go to, highlight it down here, you press the second button, and then your variables, VARS, to distributions, and then you're going to have to scroll down, or what you could do is press the up button and start from the bottom. And in some of your calculators, in the older TI-83 pluses, it might be 0. For those that have the 84s, it might be listed under A. Okay, my 84 Plus Silver Edition, it has it listed under A, and then Binome CDF is listed under B. So I'm not for certain for those with an 83 Plus. I'm sure your Binomial PDF is under 0, but your CDF, I'm assuming it may be under the A instead. There's one command that they added to the TI series between the 83 and the 84, and that is, I'm trying to think, it is the inverse T command, which in my calculator is the fourth one. It's 2 below normal CDF. If you try to find the inverse T command, which most of you really won't know what that is quite yet, in the 83s it won't be there. In the 84s it will be there. And when later we get to having to use the inverse T function, I will give you those with a TI-83 Plus, that program. So that way you will have it on your calculator like most others with the newer calculators do. Alright, now to use the calculator. There are 3 parameters, there are 3 values that we're going to have to use in the Binome Pdf command. And those 3 parameters are n, p, and x. And n and p should be hopefully obvious at this point. N is our number of trials, p is our probability of success, and x is really our k value. How many successes do we want to have here? Now, PDF stands for, it's not what you think of with Adobe Acrobat and reading a PDF file. It represents a probability distribution function. Okay, It's basically like when we made our table, like we've been making tables this whole chapter, like even with your scratch-off ticket activity, when you made a probability model, you were really doing a PDF, a probability distribution function. Now, let's do this example that's right up here. It says we will use the Binome Pdf when we want to know the probability of getting exactly 2 hits out of 5 shots, or getting exactly 1/6 when we roll a die 3 times. So for example, let's go ahead and let's re-talk about the example we primarily worked with in the last video. And that was we had a basketball player who was going to shoot 4 shots, and he had a probability of success of 75% of making a shot. Okay? Now again, Binome Pdf we're going to use when we want to know an exact number of successes. Okay? So let's do this problem here. We want to get exactly 2 made shots out of 5 altogether. So let's change our 4 now to a 5. So in your calculator, you would type in Binome Pdf. You'd go to that command. And then again, your first value is your n, which would be 5, comma, the probability of success, p, which is our 0.75, comma, x, which is our number of successes. And in this case, I want 2. And then if you close your parentheses and press enter, that will give you the probability of getting exactly 2 made shots out of 5. So if I were to type that in my calculator real quick here, that would give me an answer of, just so you can double check here, 0.08789. Okay, so this calculator command is the same thing as what we did in the last video in doing this. 5 combination 2 times, here's a made shot, we want 2 of them, here's a missed shot, we want 3 of them. That this is the same thing as doing this right here with our calculator. Now we still have to show that work to get full credit on the test and the AP test. The AP test isn't about how much you know how to use your calculator. It's about, do you understand the formulas involved? And then if you know the calculator commands, you can use them as a shortcut. Now Binome CDF. Anytime you see the keywords like at least so many shots, or at least so many successes out of whatever, or more than, anytime you're going to be using an inequality, a greater than or a less than sign, you're going to want to use Binome Cedia. It will add together all of those combinations that are at least or more than however many successes out of however many trials. Okay? Now again, there are 3 parameters with Binome Cedia, n, p, and x still, where n is the number of trials, p is the probability of success, and x takes on a little different value here. It is the number of successes, but it's the maximum number of successes. Okay? And here is a key thing to remember here. The Binome CDF always adds from the left. And what I mean by that is, if you have, say, 0 successes, 1 success, 2, 3, 4, ... all the way up to n successes, Binome CDF will always start and add all the individual probabilities from the left. It will start at 0 and add the 1 case and add the 2 case until you get to your maximum, which let's say is 3. It will add all of these together from the left. It will never start with your n, your total number of trials, and go down to the left. Okay, so it's always from the left, not to the left. And you'll see what I mean when we do some examples later on. We'll sometimes have to use a little bit of a trick to be able to account for that. Now, CDF represents a cumulative distribution function. We're going to be cumulatively adding together probabilities, multiple probabilities. So for example, in the last video we talked about that the basketball player made at most one shot, which was really equal to x is less than or equal to 1. Okay? Now, what we could do is we could do a Binome CDF command here, because this is really going to give us our x equals 0 case plus our x equals 1 case. Now, we could do this with our CDF command, or we could do two individual PDF commands, because PDF commands, again, were for exact cases when you're going to use an equal sign. So if you have equal signs, PDF. If you have a greater than or less than sign, you're going to be using, typically, a CDF binome in your calculator. Okay? So let's work out a couple of examples here. So we're going to go back to our having 3 kids and hoping for girls here. So the probability that a couple has 0 girls. Okay? Now we're talking about an exact case here, exactly 0 girls. So in that case, we're going to use Binome Pdf here. And n is our number of children we're going to have, which is 3. Probability of success is a half, 0.5. And we want the number of successes, the number of girls, to be 0. So if you were to type that in, you should end up with our value that we had before, which I'm trying to remember what it was off the top of my head. It should be 0.0125, which was 1/8. There was 1 out of 8 ways of having no girls, and that was having all 3 boys. All right. One thing we could do here, and I'm not really going to mess too much with this, is we could figure out what all of these are by not having to type them in individually into your calculator. This isn't really going to come in handy too much, but if you want to follow the steps here, you certainly could. One thing you could just do is once you've put 1 in, so let's say you've typed in your calculator Binome Pdf 3, 0.5, 0, and then you press enter and you get the 0.125. At that point, some of you know about this little shortcut trick, but if you press enter or second enter in your calculator, it will bring back this command. And you can go back and re-alter the numbers. So all you really have to do is press second enter to bring this back up. Just go back over to your 0 and replace it with the 1. Press enter, and you'll get 0.375. Press second enter to change the 1 to a 2. Press enter, 0.375. Press second enter to go back to the command. Type in 3. Press enter, 0.125. Now, if you had, let's say, 10 trials, if n was 10, it might benefit you trying out this command. I don't think I've ever really done this before, because typically the number of trials are relatively low, and you don't really need to figure out all of them to do these problems. So if you want to do this, you certainly could. Then here's our probability histogram. Here's our number of successes, 0, 1, 2, 3, and the probability of success here. So if you want to jot that down real quick, you certainly could. Okay, now, using Binome Pdf versus Cedia. Okay, and I'm going to show you both ways, and you're going to quickly see, out of the PDF or CDF scenario, which one's going to be the time saver, which one's going to take you much less time to do. So if we look at the example, the probability, find the probability that the couple has less than 3 girls. Okay, so less than 3 girls. We could write that as x is less than 3, which really means we could have 0, 1, or 2 girls. Then you might think, well, couldn't we just use the complement rule and take 1 minus the 3 case? Yeah, that would really be a lot quicker. But I just want to show you here if you didn't use the complement rule. So we have 0, here we have 1, here we have 2. You would have to use Binome Pdf 3 times and add together those 3 individual results. And you would get the final answer of 0.875. Now, using Binome CDF, okay, since we're saying less than 3 girls, that really means, another way we could rewrite probability of x is less than 3 is the probability that x is less than or equal to 2 girls. Okay? Now, this 2, and the only reason why I write this, is this 2 represents the maximum number of successes we want, which is how the Binome Pdf command in your calculator works. It works with the maximum number of successes. So in your calculator, if you did Binome Cedia 3, 0.5, 2, the most girls we want to have here, what that's going to do is take these 3 individual things and do them all together at the same time for you. And if you put that in your calculator, you get the same 0.875 that we did up here. So what would you rather do? Use the calculator 3 times to add together individual results, or use the calculator 1 time to get the final answer? I think you will clearly see that using CDF, Binome CDF in this case, is definitely going to be a time saver. Now, here is a scenario that I was kind of mentioning earlier of how we're going to have to watch out for the maximum number of successes. So find the probability that the couple has more than one girl. So more than one girl means x is greater than 1, which really means we can have 2 or 3. Now, 3 is the maximum number here, but we're not going to include every number below it. If we said 3 is the maximum, that means we're going to include 2, which we want, but it also includes the x equals 1 case and the x equals 0 case, which we don't want. So here's where we're going to have to use the complement rule. We want the 2 and the 3 case, which means we don't want the 0 and 1 case. So what I'm going to do is use the complement rule and take 1 minus the maximum number, this 1 right here. This is the maximum number I don't want to see. I don't want to see 1 or fewer. I want to see beyond that, which is my 3 and 2 case. Now you could just do 2 Binome Pdf cases here. You could do Binome Pdf 3, 0.5, 2 plus Binome Pdf 3, 0.5, 3. You could just do that since there's only 2 of them. Punch that in your calculator and you should get 0.5. Or you could take 1 minus Binome CDF of the cases that you don't want to see, the maximum number, which is 1. Now, for the bottom part down here, not really going to be doing this a whole lot, but if you wanted to see, and we've done this before, this is kind of our ogive, if you remember from chapter 1. I think it was 1 or maybe 2. The ogive was the cumulative probabilities until they keep adding up, and we get 100% in the end. So having 0 girls was our 1 in 8, or 0.125. But then to that we add the next probability. So to this we would add the 0.375 of getting exactly 1 girl. To that we would add the probability of getting 2 girls, which was another 0.375. So add that on cumulatively, and there's 0.875. And then add on the case of getting all 3 girls, which was 0.125, and we end up with 1, or 100%. So by the time we've gotten 3 girls, we've covered all the different ways, and there are 100% of our outcomes. So our ogive always ended up at the very end at 100%. So if you want to pause the video, write that down real quick, you could. Again, not really going to be doing a whole lot with a cumulative probability histogram. Okay, our ogive, if you will.